Hello, in this video, I'm going to briefly explain this research project along with the live demo. This project is a collaboration with the University of Virginia and Auburn University. Our work focuses on how people interact with explanations generated by large language models. Today, models like GPT often produce long and text-heavy reasoning, what we call the chain of thought explanations. While these can make the model thinking more transparent, they're not always easy for human to read or verify. So instead of changing how model reasons, we explore changing how its reasoning is presented. We created 4 interactive explanation interfaces that transform the same reasoning into different formats, such as structured text, code, and visual graph, to help users follow the logic step by step. Next, I will do a short demo and walk you through the entire user experience. So this is the first screen participants will see. They're asked to choose an evaluation interface, which determines how they will see the model reasoning. Prior to this experiment, each participant is pre-assigned to one of the 4 formats that were shown earlier. Since the participants already know which format they're assigned to, all they have to do is press a button corresponding to that format. After selecting a format, participants land on this instruction page. It explains the full task. They will review explanations for 10 math problems and decide whether the final answer in each explanation is correct or incorrect. We also tell them that some explanations contains intentional errors, like a calculation error, counting error, and hallucination errors, etc. And they must identify the first step where the error appears. Once they are ready, they click Next to begin the study. Here is the chain of thought version, which serves as our baseline. On the top, we have the question, in this case, calculating the square footage of a bathroom. On the bottom, the reasoning appears as a long, step-by-step text explanations. Participants will read the reasoning and then answer, is the final answer correct or incorrect? This is the way most large language model explanations appears today. Linear, detailed, but often overwhelming. It's easy to lose track of steps or overlook small reasoning errors, which is why we wanted to test the alternatives. This is the interactive chain of thought format. It keeps the same reasoning content, but structure it into numbered, colored steps. The left panel summarizes the key information, while the right side shows each step clearly separated and easy to follow. For example, the first step calculates the total width in inches, step 2 converted into feet, so on and so forth. Participants can click play to run through the step automatically, or you can click next step to go one by one. This structure helps user process information more easily. Next is the interactive program of thought interface. The reasoning appears as short Python program, and participants can execute it step by step. As they move through each step, the variables update dynamically in the panel below. This design gives participants a procedural understanding of reasoning, almost like debugging the model's logic in real time. Finally, this is the interactive graph format, the most visual format. The question and summary are displayed on the left. On the right, the reasoning appears as a graph of connected nodes, where each step are represented as connected nodes and edges. This helps users visualize logic flow of reasoning and see how each piece connects or where a wrong value might propagate. And that's pretty much the whole experience for our participants, from choosing interface to completing reasoning task. Through this project, we wanted to see if changing how explanations are presented can actually make people understand large language model reasoning better. Overall, our goal is to move away from the long wall of text that models usually generate and towards more interactive explanations that help people understand AI reasoning in a more natural way. Thanks for watching. I hope this gave you a good sense of what we're doing and why it matters.